In this lecture, we are going to discuss about hexadecimal to decimal. Hexadecimal to decimal. Right. Here, now you assume that one, the number is f of. F of in hexadecimal, we have to convert into decimal. So for that f of, we are getting now that decimal is 255. Now, here, how do you convert that one? In that assembly language programming, how do you convert that one as here in that f, first you have to check whether it is greater than 64. So if it is 64, then you have to subtract one time. Then here f is 15, 15 minus 4, 11. 11 is we are having now b. And 15 minus 6, 15 minus 6 is 9. Then this is greater than 64. Once again, we have to subtract 64. You will get now 11 minus 4, 7, and 9 minus 6, that is 7. Right? So, 2 times we are having now 64. The 64 is equivalent to, in hexadecimal is 100. 64 in hexadecimal is equal to 100. So, here we are having now how many number of times hundreds are there? So, 2 times we are having 100. So, the 100 digits we are having the value 2. And then that 37, now you have to find out how many number of tens. So for tens, we are having now 0a. In hexadecimal is equal to 10. You have to subtract 0a from the 37. So 37, so you are taking one carry, one borrow here. Then you'll get now that 16. 16 plus 13, 23. 23 minus a is, we are having now d. And we are getting now 2d. 16 plus 7, 23. 23 minus a, 13. 13 is d. Then we are having 2d. Then once again you have to subtract. Because it's greater than 0a, you have to subtract. d, 13 minus a, 3, 23. Then this also greater than 0a, you subtract. You will get now, you take one borrow. So this is 1. Here we are having 16. 16 plus 19. 16 plus 3, 19. At minus 10, 9, 1, 9. This also greater than 0a. So you have to subtract once again. 9, you take borrow. 16 plus 9, 25. 20 minus a, 0f. Here also we are having now 0a. 1 greater than 0a. You subtract. You will get now 0.5. Here we are having now that how many number of tens are there? 1, 2, 3, 4, 5. So the tens are 5. And then the remainder is one's digits. So that is 5. You will get now the result is 0 to 0, 5, 0, 5. So we are storing the content into the location, one location, another location, and another location is this value. So this value combined together is we are getting now that decimal form. So hexadecimal to decimal conversion we have to, right? So it's a simple way. So we can easily implement that one. So here, how do you start now, right? Here you are taking one counter. So for that we are using C register. The C register is cleared. And B register also is going to be clear. We are getting now 2 registers ready for counting. Now you take your value. In 4300, we are having now that FO. 4300 is the location where we are having now FO. This FO is moved to accumulator. So this FO moved to accumulator. Accumulator is currently having your value, hexadecimal value FO. Then we have to compare immediate with 64. So we are comparing that one, whether it is greater than 64 or not, right? If it is carry, it's not greater than 64. So there is no hundreds digits. Then you have to go for the tens digit. Or otherwise, here we are having now that there is no carry. F of minus 64, it won't form the carry. So here compare immediates is doing now. Just try to subtract and it will change the flag register. So here there is no carry. Then it will come to subtract 64. Then increment C. Then once again jump to this location, and once again we are comparing. Then here once you are subtracting this one, you will get now the result in accumulator 0A. And once again it is comparing with the greater than 64. Yes, greater than 64. Then you have to subtract. So here subtract immediate one 64. Now that A is 37. Then once again check now. Then the carries occur. Then it will come to here, this location L1. Now it will compare with the 0A is a greater than, and then you have to start with subtract. So greater than 0A. So that loop is moving now, right? So this is the loop. The L1 loop is moving now. Here 0A one time, two times, and three times, and four times, right? So like you have to give now, at that time we are incrementing B. So C register is having that content digits, and P register is having tens digits. Then you have to do that one. After completing that one, we are having the remainder is the ones digits. Then the ones digit is in INX H, right? So here we are having now the C is tens digit. Okay. Now the C is tens digit. We are storing now in the 4301. 4301. We are having C content. C is 02. And then B is, we are having increment H. B is here. And we have to move to that one as 4302. We are having P register is how many number of 0A. So the P register is increment by 1 by 1. So we are getting now 5. So this is a B register content. B register one time. P register two time. P register 3, increment that one, right? 4 and 5. We are getting now the contents digits. Then 4303, we are having now the accumulator is the remainder. The remainder is 05. This 05 is moved to this location. We are converting now. That's all.